My name is Daniel Cashmore and I'm an MSci undergraduate student studying Palaeobiology and Palaeoenvironments here at the University of Birmingham. And my objects of the month are these Late Carboniferous tetrapod footprints from Aveley in Shropshire. The footprints themselves are made by several temnospondyle amphibians, and temnospondals are ancestral forms of modern-day amphibians like frogs and salamanders. The tracks preserve the impressions of both the forefeet and the hind feet of the animal, and a larger specimen here shows you this clearly. Here's the forefeet and the hind foot, and they overlap because of the way the animal moved and was travelling across the sediment. Tracks like these can be used to understand how the animals moved and even tell us how fast they were going. This specimen here, for example, shows a trace of one of the animals dragging its tail behind itself as it walked. My object of the month is one of many other specimens derived from the red sandstone beds of Aveley in Shropshire. Altogether, they form an extensive and diverse community consisting of early reptiles and amphibians. The majority of these trackways were found by Dr. Frank Raw in 1914 and 1919 and have been housed in the Lapworth Museum ever since. The collection consists of over 200 individual trackways and is the most complete collection of tracks of its age in the UK. The footprints are preserved within sandstone layers and would have formed in very shallow water within an ancient alluvial floodplain. The actual footprints themselves are preserved as convex hyporeliefs, which means that they are raised up instead of actually being depressed like the original footprint. So what we're seeing is actually a natural cast of the original footprint. The actual footprints themselves would have been formed within a different layer of sediment, say like a soft mud. Then after rapid deposition of the sandstone layer on top of the soft mud, the sand would infill the imprint on the mud and preserve it as a positive relief on the base of this sandstone layer. The footprints are quite significant because of their age. Their presence in the fossil record has extended the range of temnospondals from the latest Carboniferous and earliest Permian further back in time to the mid to late Carboniferous. The actual assemblage is also important because it marks the transition from an amphibian-dominated community to one dominated by reptiles like that of the early Permian. And I personally believe it deserves Object of the Month because it preserves a specific moment in time that several animals walked across a floodplain some 310 million years ago, and I find that quite amazing.